Find all values of x for which f of x equals 8. So we're given f of x equals the square root of x squared minus 17. This is a function, it's not an equation, but they give us this equation f of x equals 8. So let's start with that. F of x equals 8. Now f of x is the square root of x squared minus 17 equals 8. So this is a radical equation, but it was kind of coded in this function notation. Now that we see that it's a radical equation, our basic steps are to isolate the radical. Notice there's only the radical on the left side, so that's isolated, and then get rid of the radical with an appropriate power. In this case, squaring both sides will allow us to get the square and the square root to reduce, leaving us x squared minus 17 on the left. On the right we have 8 squared, which is 64. Now, to solve for x, we have just this x here. It's squared in the minus 17. If we can successfully get rid of the minus 17 in the square, we'll just have x. So let's go for that. Let me add 17 to both sides. That leaves us x squared equals 81. Now some of you are thinking, oh, the answer is 9. There's two answers. When you take a square root, when you're the one that creates a square root to get rid of a square, you also have to create that there are positive and negative principal square roots on the other side. So this gives us x equals negative 9 and positive 9. And for a quick check, we want to make sure that f of x equals 8. If I set the function f in blanks, it'll be the square root of blank squared minus 17 equals 8. If I plug in negative 9, that will reduce to 81 minus 17. That's the square root of 64. That equals 8. Check. And if I were to check the positive 9, I will get the same results. That's the square root of 81 minus 17, which is the square root of 64, which equals 8. So these are the two x values. Find all values of x. We have the two x values, and we've checked that they make f of x equals 8. And on that note, I hope this helps.